We live in a world where artificial intelligence can paint award-winning digital masterpieces, conjure entire imaginary cities out of thin air, and perfectly replicate the style of Vincent van Gogh in a matter of seconds. But despite all of this godlike creative power, there is one painfully simple thing that causes the world's most advanced AI to completely lose its mind: drawing a normal human hand. Why does a multi-billion-dollar supercomputer suddenly turn into a toddler with a crayon when it comes to drawing fingers? Welcome back to ByteSized Tech, the digital arcade where we decode the most entertaining and mind-blowing facts about technology and artificial intelligence. If you have ever played around with free AI image generators like Digital Maker AI, you have almost certainly encountered the creepy hand phenomenon. It has become one of the biggest memes on the internet. 6 fingers, backwards thumbs, and wrists bending in ways that defy physics. But what is actually going on inside the machine's brain to cause this? By the end of this video, you will know the exact computer science secrets behind this hilarious glitch, and you will understand how artificial intelligence sees the world in a way completely different from you and me. Let's dive in. To understand why AI struggles with hands, we first have to understand how an AI image generator works. When you ask a human artist to draw a hand, the human understands underlying anatomy. They know a hand has bones, joints, muscles, a palm, and exactly 5 digits. But an AI doesn't know any of that. AI image generators do not understand 3D space, physics, or biology. Instead, they rely on complex pattern recognition across billions of pixels. When you prompt an AI to draw a hand, it searches its massive database of billions of images for pixels that correlate with that word. It understands that hands usually consist of skin-colored pixel clusters near the end of an arm, usually with several long parallel shapes attached to them. But it has absolutely no concept of why those shapes are there. It's just guessing where the colors belong based on math. Reason number 2 is that the human hand is arguably the single most mechanically complex part of the human body. Think about it. You have 4 fingers and a thumb, and each finger has multiple joints that can articulate in different directions. Even professional human artists spend years taking life drawing classes just to master the geometry of the hand. Now, imagine trying to figure out that geometry just by looking at flat, 2D pictures. Depending on the angle, a hand can look like a closed fist with 0 fingers visible, a peace sign with 2 fingers, or an open palm with 5. Because hands change shape so drastically depending on the viewing angle, the AI's pixel matching algorithms get incredibly confused. It tries to merge the data of an open palm with the data of a closed fist, resulting in a terrifying, mangled hybrid. Number 3 brings us to the actual data the AI was trained on. To teach an AI what things look like, tech companies feed it billions of photographs from the internet. But think about how hands usually appear in photos. They are almost never perfectly flat and spread out. They are usually holding objects, like a smartphone, a steering wheel, or a coffee cup. They are resting in pockets, intertwined with other people's hands, or partially blurred because they are moving. Because the training data is full of hands that are partially obscured, the AI learns a very messy definition of what a hand is. When you ask it to generate a clean, empty hand, it panics. It looks at its messy data and basically says, well, usually there's a bunch of skin-colored tubes overlapping here, so I'll just throw 7 or 8 of them into the picture to be safe. Let's talk about number 4, the spaghetti effect. AI models are designed to aggressively fulfill your prompt. If you ask for a detailed, high-resolution portrait, the AI wants to pack as much texture and detail into the image as possible. When it gets to the edge of the wrist, its algorithm knows that it needs to generate fingers. But without a hard-coded biological rule that says, stop at 5 fingers, the AI gets caught in a loop. It generates a finger, looks at the adjacent space, calculates that another finger would fit the pattern perfectly, and just keeps going. It treats fingers like a repeating texture pattern, similar to how it would draw the scales on a fish or the individual leaves on a tree. If it has extra canvas space, it will just keep planting more fingers until it runs out of room. Finally, at number 5, we have to talk about the future. Will AI ever figure out how to draw hands correctly? The answer is yes, and it is actually happening right now. The newest generations of image models are finally moving beyond just guessing pixel patterns. Software engineers are beginning to integrate actual 3D skeletal frameworks into the AI's training process. Before the AI lays down the pixels, it essentially builds an invisible 3D skeleton with a set number of bones, forcing the AI to strictly adhere to human biology. We are currently living in a very brief, hilarious window of internet history where AI is smart enough to generate photorealistic worlds, but still dumb enough to give you 7 fingers. In a few years, the creepy AI hand meme will be completely obsolete. It's pretty fascinating how something so simple for humans can break the smartest machines on Earth. Have you ever tried an AI image generator and gotten a terrifying alien hand? Let me know your funniest AI glitch stories down in the comments. I love reading them. If you enjoyed this deep dive into the weird world of artificial intelligence, make sure you hit that like button and subscribe to ByteSized Tech. In our next video, we are going to look at another incredible piece of tech history. The first computer bug was actually a real physical bug. You definitely won't want to miss it. The digital world is full of wild glitches and secrets, but we're here to explain them all. Thanks for watching. Keep your curiosity alive, and I'll see you in the next one.